foundation trigonometry exam. So the first one here, 3 angles ABC marked on the diagram, and using the diagram write the letter which represents each of the types of angles listed below. So start with obtuse. So an obtuse angle is an angle that is bigger than 90 degrees but less than 180, so that would be B. A reflex angle is an angle bigger than 180, so that would be C. And then the acute, oh no, sorry, I actually have that wrong. Let me go back. I looked at that wrong. So the obtuse angle is the angle greater than 90, less than 180, so that's A. Apologies for that. And then your acute angle is your angle less than 90, which is definitely B. All right. So, B. So the diagram shows a right angle triangle. One of the angles is marked as A. Complete the sentences below. Sentence 1, the length of the side opposite angle A. So here's angle A. Opposite angle A there is your 2. And sentence 2, the length of the hypotenuse of the triangle. So the hypotenuse is the longest side, and it's also always opposite the right angle. So here's the right angle. So opposite the right angle then is your 5 centimeter line. So next 2 parts. So use the lengths of the sides in part 1 to write down the value of sine A. So if you go to page 22 of the Formula and Tables book, you will find that sine A is A over C. Okay, and if we go back up here, this side is the hypotenuse, and the hypotenuse is C. This side we said was the opposite, and the opposite is A. And then the spare side down here, the adjacent, is B. Okay, so for sine, it's A over C, so we have to put A, which is 2, over C, which is 5. And then use your calculator to work out the size of the angle A. So sine A equals 2 over 5. We are trying to find A. So we need to take this sine and move it across the equals. When you do that, it becomes sine minus 1. So we have A equals, and you do your shift sign to get sine minus 1. And then 2 over 5 gives me 23.578178848. That's what my calculator says. Question says, give your answer correct to the nearest degree. So the nearest degree means I stop there and look at the next number, which is a 5. The 5 is big enough to push that number up. So it won't stay 23, it'll become 24 degrees. So that's question 1. Question 2. So the rectangle below has a number of axes of symmetry. Dara says it has 2 axes of symmetry, whereas Mandy says the rectangle has 4 axes of symmetry. So who's correct? Is that working? Dara is 2 axes of symmetry. And then they are asking us to draw the axis of symmetry. So the axis of symmetry is going to be 1 down here and 1 across there. Okay. Okay, so the next bit here is a construction. I'm not going to be able to show you this properly, but I'll try and talk you through it. So construct a triangle with all sides 7. So they've done the base for you. So then what you would do is you would take your compass and you get your ruler and you open up your compass. You put your pin at the start and you put your pencil at 7. So now you have your compass at the right width, and then you use your compass and you strike an arc from A, and then you go, keeping the compass the exact same, you strike an arc from B, and then you just join these bits up. So you join A up to here, and you join here to B. And if you've done it right, this should be 7 and this should be 7. Okay, so all you need is your ruler and your compass, and you open up your compass, pin of the compass on 0, pencil of the compass on 7, come over here, put the pin down on A and draw an arc, change nothing about the compass, put the pin down on B and draw an arc. Where the arcs cross, make a dot, and then join the dot to A and join the dot to B. Okay, I can draw that for you using an actual compass. I just can't do it like a video. I can't do it live. I don't have a visualizer. So moving on. Put a tick in the box. Let's say put a tick in the correct box to show what type of triangle it is. So because it had all the 3 sides are the same, it's equilateral. 3 sides, same length. That's what an equilateral triangle is. So a ladder is placed against a vertical wall of height 7 meters as shown. The base of the ladder is 2 meters, so that's here from the wall. It says the wall is a vertical height of 7 meters, which is here. Use the Theorem of Pythagoras. So we see Theorem of Pythagoras, we go to page 22, and we get the Theorem of Pythagoras, which is this. Go to your triangle. Here's my right angle, which means across from that, that's my hypotenuse, and my hypotenuse is C. Here we have the opposites, which is A, and then down here we have the adjacent, which is B. Okay, so put everything in the right place. So C, I don't have a number, I don't know what the ladder is. That's my question, find the length of the ladder. So I'm just going to leave C as C. A is 7 and B is 2. So 7 squared is 49 and 2 squared is 4. So C squared is equal to 49 and 4, which is 53. And then to get rid of this square, I have to do a square root. But if I square root one side, I have to square root the other side. So I get C equals square root of 53 on my calculator is giving me 7.280109889. The question says 2 decimal places. So I go 1, 2, and I'm going to stop. The 0 is too small to have an impact, so it stays as 7.28 meters is the length of the ladder. Okay, so another construction here. Alright, just get the whole box in. And again, I'll just have to talk you through it. So, you're going to have 8 centimeters, you're going to have 6 here, you're going to have 6 here, and you're going to have 8 here. Okay? So the first thing you do is you get a ruler and you just draw a line 8 centimeters long. Okay. Then what you can do is, I'll try and draw this and take it off. You know your protractor? So this thing? Yeah? So you put that down, find where it says 90 and put a mark. Okay? I'll try and take that out again. So you put your protractor down, find where 90 is and put a mark, and do the exact same thing over here and put your mark down at 90. Okay, next thing we want is a 6 centimeter line. So you do that the same as a minute ago. You get your ruler, you get your compass, you put the pin of your compass on 0 and you put the pencil on 6. So now you know it's open to 6 centimeters. You bring that compass over here, you put the pin here, and then you strike an arc, and then over here, put the pin here, and you strike an arc. Okay? You then draw a line going up through the mark and hit your arc. Same thing here, go up through the mark and hit your arc. And then you should just have to join here to finish it off. Okay, so again, that's clearly not done correctly. You have to do it with all the equipment I'm talking about, and all your lines will be perfectly straight and all that. But that's how you do it. So again, give it a go. If you're still having trouble with those constructions, I can try and come up with a different way to show you how to do them. Okay, so find the perimeter. So the perimeter is the edge. So the edge is going to be 8 plus 6 plus 8 plus 6, which is 28 centimeters. The area, so the area of a rectangle, you do length multiplied by width. So the length is 8 multiplied by the width is 6. 6 eighths are 48. That's for the area. Draw the diagonal. So you literally go back up to your diagram and you will draw in a diagonal, again with a ruler, and make sure it's straight. And then it says measure and write down the length of the diagonal you have drawn in D part 1. And I don't, well, I can figure out what length it is. Let's see what's the next question. Yeah. So I can't measure it because I obviously didn't construct mine properly. So just have a look at this. So use the theorem of Pythagoras to show that you measured the length of the diagonal correctly. Okay, so there's a right angle here, which means this is the hypotenuse. Yeah, this here is your opposites, and then this here is your adjacent. So this is C, this is A, this is B. We know that this, because we drew it that way, is 8 centimeters, and we know that this bit here is 6 centimeters, and we're trying to figure out what this is. Okay, so Theorem of Pythagoras, page 22, C squared is A squared plus B squared. So C squared is, what did I say A was? 8. So it's 8 squared plus 6 squared. So C squared is 64 plus 36. So C squared is 100. And then to get rid of my square, I square root both sides. So I get C is 10. So in this part here, when you measure it after constructing it, you should get something around 10. Okay, so if you got like 9.8 or 10.1 or something like that, once it's close to 10, you'll get full marks for that question. Okay, and one property of a triangle, so that's literally something about a triangle that would count for every triangle. So you could say opposite sides are the same length. What else could you say? Oh, the angles are all 90 degrees. Now, you wouldn't have to say both. You only need one property. So there's 1 and there's 2. Doesn't really matter. So a property is something about a shape that is kind of characteristic of that shape. So what does every single rectangle have in common? They would all have 2 sides the same, like top and bottom are the same, or left and right are the same, so opposite sides are the same, and they all have 90-degree angles. Their corners are all 90. Alright, that's it.